Welcome and thanks for watching the first law of thermodynamics, problems in solid phase. This is part 1, and I like to show that the law is not universal. In 1845, based on his pedal wheel experiment, Joules postulated the mechanical equivalency of heat. The law is the postulation, also known as the first law of thermodynamics, and usually written as the sum of the differentials of heat and work as du, where u is the internal energy, is equivalent with dq, where q is the heat, plus dw, where w represents the work. So this would be the equivalency, the work supposed to be transferred to heat and vice versa. Joules' original experiment was the following. He demonstrated the equivalency by using the mechanical energy of a falling weight, and that mechanical energy was transferred to a rotating wheel, a paddle wheel, in a liquid. System was isolated, and the thermal energy of the liquid been measured by a thermometer. It has been shown and demonstrated that the work done by the falling weight completely transferred to heat. And based on this experiment, the law was postulated, as I mentioned before. I like to point one important part in this. The experiment demonstrated only in a liquid and only the transformation from the work to the heat side. Reverse transformation never been experimentally verified. If you heat up a liquid and you have a weight on the top and you add some heat, the heat will never be completely transferred to mechanical work. So the transformation works in liquid phase from work towards heat, however, doesn't work in a reverse. The same applies in solid phase. If I do work and I'm assuming elastic solids, the work basically 100% recoverable. That's the definition of the elasticity. Elastic work is 100% recoverable. So what else left to heat? A very little can transfer, because we do know there is thermoelasticity, and the elastic deformation affects a little bit the heat part, but not the whole. There is no complete transformation. So it doesn't work this direction, and of course doesn't work the reverse direction. We do know from experiments the transformation between work and heat works very well in gas phase in both directions. So from this you can see that there are a couple of points where Joules' postulation doesn't work. And that's why I'm suggesting the law is not universal. And the explanation behind the lack of universality lies because the energy is stored in a different physical process. The law is true when the energy from work and heat is stored by the same physical process. Like in gas phase, if you do work on a system, that will increase the translational kinetic energy of the gas or molecules. And in the same way, if you apply heat to the system, that will increase the translational kinetic energy of the molecules. So in both sides, the energy is stored by the translational kinetic energy. Therefore, in gas phase, it's completely interchangeable. You can change work to heat and back and forth. This is not true in liquid phase from heat to work direction. And in case of elastic solids, it's not true neither of the direction. If the work causes atomic vibration, like in case of friction, then the work can completely transfer to heat, because the work part is stored by the same kind of physical process, vibration plus the heat. And the same is true if the deformation is plastic. The plastic deformation will result in atomic vibration, therefore it's transferable to heat. But elastic deformation will not, because that's stored by elastic deformation. I hope I raised your curiosity, and you will watch part 2 and 3 where other problems with the first law will be exposed. Thank you.